Hello everyone, welcome back to mahafarkar.co.in. In today's video, we are going to learn about heat engine. Before proceeding with the heat engine, we need to go through the second law of thermodynamics. Logically imagine kara, if you are providing heat to any object, that object can do the work. जेवढी heat, तेवढं work. So heat can be completely converted into work. But can work be completely converted into heat? Logically, some statements, contrary of these statements are not valid. So, in very simple words, I would say mechanical work can be completely converted into heat. Okay. If you provide W amount of work, then W amount of heat, Q amount of heat can be generated, where W is exactly equal to what? Q. But if you provide Q amount of heat, then can we get W amount of work? Then I would say answer is no. Why not? Because heat provided to the system can be used by the system as well as it can be used by what? Surrounding also. Or some system can be absorbed by the system and some heat can be what? Rejected by the system. And because of that, we cannot completely convert the heat into the work. And this statement can be called as what? Second law of thermodynamics. The heat engine works on the same basis, but it is a cyclic process. Now, before that, before again proceeding with that, we know that work done due to heat dW can be given by P into dV, where P into dV is what? Final volume minus initial volume. Okay, this already we are knowing. So what is heat engine? Then I will say the engine or device which converts heat energy, heat energy into work, then that device is called as what? Heat engine. Now how it works? So for that, some important terms are required. The first is source of heat. Now, for example, if I am considering the engine of bike, then source of heat can be by the means of what? Fuel and some vapors of the fuel. Okay, fuel vapors produces heat and that heat can be used. Second is the basic engine. Now, this engine consisting of movable frictionless piston. Movable and frictionless what? Piston. Okay. And the finally, there is the third term which is used to reject the heat. Means I will call that term as what? Sink. It used to reject the heat. Here rejection of heat is the loss of heat that we are going to keep in mind. Now, when we discuss the heat engine in a detail, what is the basic general diagram, block diagram of heat engine? Then I will say, suppose this is the source of the heat. This is the actual engine, and finally here there will be the sink, or I will call hot reservoir, and this will be called as what? Cold reservoir. Okay. Hot reservoir is going to produce the heat and that heat is going to send the engine. Okay. See now, suppose Q1 is the heat produced in this source. Now what is the source? As I said, if it is the bike engine, then fuel vapors burns when you are kicking the vehicle. तुम्ही जेव्हा किक करता vehicle ला, पेट्रोल कार्बोरेटर मधनं एक फ्युएलच्या फ्लो मध्ये फॉर्म होतं. इट फॉर्म्स द वेपर, इट गेट द वेपर अँड इट बर्न्स. ते बर्न झाल्यामुळे ती हीट पुढे पास होते. हीट पुढे पास झाले इंजिनला. नाउ इंजिन कन्सिस्टिंग ऑफ मूवेबल अँड फ्रिक्शनलेस पिस्टन. आता इंजिनचं जर मी अजून स्ट्रक्चर विचारात घेतलं तर इंजिन मे बी लाईक दिस. it may be consisting of one cylinder, okay, and with the piston, cylinder with the piston. Now suppose heat is provided from this side, heat Q1 is provided from this side. So here the system and this piston is connected to the axle like this. Suppose आता हा असा move झाला, then it will rotate the vehicle, wheel of the vehicle like that. So if you provide the heat, then this piston on which pressure will be increased. Okay. So if this is the initial position of the piston Vi, because of pressure it will get expand. The system will get expand and will suppose reach to here Vf. System is expanded. Because of that expansion in a system, piston will move up. Piston move झाला तर समजा इथे एक्सेल पिस्टनला असा कनेक्टेड आहे एक्सेल आणि पिस्टन असा मूव झाला तर हा एक्सेल असा काय होणार आहे तिथे रोटेट होणार. दॅट मेकॅनिकल अरेंजमेंट इज डन देयर टू रोटेट द एक्सेल. ओके. नाउ लॉजिक लक्षात घ्या. इथून या इंजिनला हीट मिळाली. इंजिन मध्ये पिस्टन होता. पिस्टन मूव्ड. सो पिस्टन हॅड डन द वर्क. Piston has done what? Work. So, say W is the amount of work done. W is what? Amount of work done. Okay. W is what? Amount of work done. Problem is that all the heat provided to this engine, that is to the system, will not be used to lift the piston. Some amount of heat is definitely going to lost. Say some amount of heat is lost here and goes to the next part, that is say cold reservoir. आपण त्याला cold reservoir म्हणूया. Actually तो खूप cold नसतो, but we'll consider it is cold reservoir. It is called sink. आता बाईक मध्ये हा सिंकचं काम कोण करतं? Then I will say बाईक मध्ये आपला जो सायलेन्सर असतो बाईकचा, जो बाहेर एक्स्ट्रा जी हीट आहे किंवा जी इथून रिजेक्ट केलेली जी हीट आहे ती बाहेर टाकण्याचं काम करतो. That silencer will be there as what? Sink. So, say some amount of heat is lost here. Say Q2 is the amount of heat lost here. So you had provided what? Q1 amount of heat. Because of that piston moved, so it has performed. W is the amount of work, and I will say heat supplied to the system is Q1. W is the amount of work done, and Q2 is the heat rejected by the system. Q2 is what? Heat rejected by the system. आता ही हीट इथून रिजेक्ट होऊन इथं आली आणि हा सिंक काय करणार? तिला बाहेर टाकून देणार. जसं आपण म्हणणार की सायलेन्सर आहे, सायलेन्सर मधनं काही हीट काय होणार? पास होणार. ओके. नाउ आता लक्षात घ्या, when expansion is done because of that heat, expansion is done because of that heat, now piston has to come back. So piston पुन्हा आपल्या जागेवर येईल. Piston will come back to its original position. Once the pressure is released, piston will come back. So at the same time, expansion झाल्यानंतर, so first stage in which what is done? Expansion is done. In the next stage again compression will be takes place. So compression मध्ये काय होणार? पुन्हा याचं टेम्परेचर कमी होणार, इंजिनचे टेम्परेचर कमी होणार. Again this will send the mechanically this arrangement will send the more heat, and again it will expand and will again compress. So expansion and compression will continuously take place. So I will consider it is kind of which process? Cyclic process. ही कुठली प्रोसेस असणार आहे? सायक्लिक प्रोसेस असणार आहे. ओके. नाउ आता इथं if I use first law of thermodynamics by first law of thermodynamics, by first law of what? Thermodynamics, I said Q1 is the amount of heat. So say Q1 is equals to, that heat is used by the entire system in two parts. Part of heat is used to do the work and part of heat is used to get rejected from the system. So according to first law of thermodynamics, W plus Q2 will be the equation, or W equal to what? Q1 minus Q2. This will be the expression for work done in the heat engine. Now we have one important term called as efficiency of heat engine. efficiency of heat engine. Logically लक्षात घ्या, how much heat you provided Q1 आणि how much work was done W. तुम्ही एखादं इंजिन इफिशियंट कसं आहे हे कसं ठरवणार? तुम्ही एनर्जी दिली आणि त्याने काम केलं. सो काम किती केलं? W आणि एनर्जी किती दिली? Q1. This ratio is called as what? Heat efficiency of heat engine. So ratio of work done by system or by engine to the heat supplied to system, this ratio is called as what? The efficiency, indicated by eta is equals to W upon Q1, as Q1 was the heat supplied. So what is W again? Eta equal to what? Q1 minus Q2 divided by Q1. So I can write eta is equals to Q1 upon Q1 is 1 divided by 1 minus Q2 upon Q1. लक्षात घ्या, this is the formula for finding efficiency of heat engine. We know that the heat rejected by system cannot be zero. This heat cannot be zero. If it is zero, then eta can be equal to 1. But in practice, eta can never 1 because Q2 cannot be what? 0. म्हणजेच काय? तर आयडियल हीट इंजिन बनणं इम्पॉसिबल आहे. का तर नेहमी काही ना काही हीट सराउंडिंग मध्ये लॉस्ट होते किंवा त्या सिस्टीम मधनं रिजेक्ट केली जाते आणि म्हणून आयडियल हीट इंजिन मिळणार नाही. ओके, आता जर मी इथं प्रेशर व्हॉल्यूम ग्राफ काढला तर लक्षात घ्या, ड्युरिंग एक्सपान्शन व्हॉल्यूम इज इन्क्रीज आणि ड्युरिंग कॉम्प्रेशन व्हॉल्यूम इज डिक्रीज. सो जर मी इथं प्रेशर व्हॉल्यूम ग्राफ जर काढला तर ग्राफ एकदम सोपा शब्दात असा मिळणार आहे बघा. प्रेशर अलॉंग P, y एक्सिस अँड व्हॉल्यूम. सो आधी व्हॉल्यूम कमी होतं, प्रेशर जसं जसं वाढलं काय झालं? व्हॉल्यूम वाढलं. कळलं काय म्हटलं ते? दिस इज ड्युरिंग एक्सपान्शन. ओके, पुन्हा रिटर्न, पुन्हा काय झालं? कॉम्प्रेशन. सो system goes from A to B and comes from what? B to A. So it is a cyclic process. So remember, heat engine is always a cyclic process. I hope you understood the concept of heat engine. It's very important article. Some theory questions along with the questions on this efficiency of heat engine can be asked in the CET. Thanks for watching mahasarkar.co.in. Have a nice day.